In this video, we want to talk about how to determine if a piecewise defined function is differentiable at a specific point there. Okay, so let's take a look at a specific example here. And in this example, we want to determine whether the function is differentiable at x equal to 4. Okay, take a look here. This function is a piecewise defined function. Each piece, you can see this piece is a polynomial. This piece is also a polynomial. So that means if there are polynomials in that piece is differentiable, this piece is differentiable. But if you want to make sure at x equal to 4 is differentiable, you have to make sure that two functions connect. But that's two pieces connect each other. Not only connect each other, you have to make sure the connection must be smooth. You don't want the connection like this or like this. So that means at this point, the function is not differentiable. You want the connection like this here. If you have polynomial like this, and the next part you're going to want this, okay, make this smooth. Okay, so the connection going to be very smooth. Then that is differentiable there. Okay, so let's take a look here. In order to make sure the function is differentiable, okay, first you have to make sure the function is continuous. Okay, is f continuous at x equal to 4. Okay, so we have to determine if the function is continuous first. Okay, let's take a look here. In order to make sure the function is continuous, you have to make sure the limit x approaches 4 and the function value at 4 must be equal. Okay, that's the first thing you want to check here. And so now, that's the first thing here. So let's take a look at the limit at x equal to 4 because it's a piecewise defined function. So here, the limit, you have to consider limit from left and from right and equal. So let's take a look here. Limit x approaches 4 from left. When it's from left, so it means that's less than 4. Less than 4 so means you use this expression. So you're going to have limit x goes to 4 from left. You're going to use x squared plus 2. So you have 4 squared plus 2, 16 plus 2, which is 18. And so here, now, and limit x from and right. From right, so here, and then you're going to use this expression because x greater than 4. So you have limit x approaches 4 from right, and that's 8x minus 14. So you have 8 times 4 minus 14, 32 minus 14. That also equals 18. And so now that indicates the limit x goes to 4 and exist equals 18. But you can easily see f of 4 in this case, which you use x squared plus 2, because this is x equal to 4, you have to use this expression, which is 4 squared plus 2, which is 18. So that tells us the limit and the function value same. So that means it is continuous. It is continuous at x equal to 4. So that's the only first part. But we also want, that only tells you the function connect. But as for if the function connects is like smooth or like this, and you mean smooth or like this, we don't know. So we have to make sure that the connection makes it smooth or like this, or like this, we have to make sure that. Okay, so now take a look here. Okay, take a look here. The derivative, okay, derivative. And what we have here, okay, we use so-called the derivative from left. So because we can use so-called alternative, okay, definition for the derivative. So here we have limit x goes to, oh, you can, we want to write this f4 from left, okay, so that equal to limit x goes to 4 and from left, okay, and that give us f of x minus f of 4 divided by x minus 4 there. Okay, when x from left, which means you use this expression, you use x squared plus 2, x squared plus 2 minus f4, which we already know is 18, okay, divided by x minus 4. So that gives us limit x goes to 4 from left. That's x squared minus 16 divided by x minus 4. So now let's take a look here. What is the limit? Obviously, in this case, I can't do the substitution because the denominator will be 0, but I can simplify the function because the numerator is difference of 2 squared, so you can write it as x minus 4 times x plus 4 divided by x minus 4 and reduce. Okay, so that's give us limit x goes to 4 minus x plus 4, which give us 8. So because now you can do substitution. So that's the left side limit. The limit from left side, actually we write this way. Limit from left side. Okay, so how about the derivative from the right side? And you can write limit x goes to 4 plus fx minus f4 divided by x minus 4. Because from a right side, so now you're going to use 8x minus 14. So limit x goes to 4 plus, so that 8x minus 14 minus f4, which is 18 divided by x minus 4. And simplify, that is 8x minus 32 divided by x minus 4. I can't do substitution, but I can take limit. I can factor out the 8 from the numerator. I get x minus 4 divided by x minus 4. So now, as x approaches 4, but that goes to 0, but not equal to, so I can reduce. So the final answer is 8. So the derivative from left and derivative from right, they are same. They are same. You can see both equal to 8. So that indicate the limit x go. That means the derivative at 4 exists equal to 8. So that function is differentiable. But maybe you said, is this really necessary? Yes, it is necessary. Sometimes you may find the function is not continuous. So if it's not continuous, you don't need to do second step. If the function is continuous, then you need to do second step. Okay, so that's how we determine if a function, piecewise defined function at a specific point, is differentiable or not differentiable. Okay.